Hello and welcome to lecture 2 in critical evaluation of intelligent robotic systems. So again, as in lecture 1, I'm going to split this up into 2 or 3 parts so that they're a bit easier to digest for you. So in lecture 2, we're going to look at critical thinking and reading and constructing a narrative, so to help you start to think about constructing your reports. So the outline is we're going to have a look at some tools for reading the literature effectively, some ideas and tips about critical thinking when you read the literature, and some ideas about how to actually write more critically than maybe we have done in the past. And then a little bit of a discussion of something called cognitive bias, which potentially changes the way people think and biases the way that you think. So it's something that we'd like to get rid of, or at least mitigate. And so we'll talk a little bit about effects of that as we're doing our reading. So first of all, let me talk about keeping track of resources. And so during the course of the assessment for this module, you're going to be reading lots of papers around the subject that you've chosen. And you need to keep track of these resources because you'll forget what you've read, or you'll remember a really good idea and you'll forget which paper that was in. And also at some point when you come to write the report, you're going to want to include these resources into your report. So you should, I mean, I hesitate to say must, but you should use a citation manager. And this allows you to collect the citation information on papers that you've read in a really nice format. It allows you to keep them as a good record in a particular order. And then when you want to include these in your report, it may be 2 or 3 months after you've read the paper, it's a way of you actually recovering that really quite easily. And I'll talk about Citation Manager in the next slide in a little bit more detail and show you an example. I really recommend that you keep notes as you read papers. And it's up to you how you do that. So it is really up to you what your favorite method of doing that is. I would suggest that you keep an electronic record rather than just writing things in a notebook. But if you really want to just keep them in a notebook, that's up to you. But I would suggest that you type your notes up in some form. It may just be as a Word document. It may be as a LaTeX document, however it is. But most of these, one of the advantages of doing that, of course, is that most of these allow you to search. So if you're looking for a key term when you're writing your report, let's say legged robots with 6 legs, then you can quite easily type 6-legged robots and it will come up searching your document, your notes of which papers have talked about robots with 6 legs. And within those notes, I would suggest that you cite them. So that means you reference them. Citing means referencing. So you reference them in a format that makes it easy for you to recover those. It allows you to detect faulty citations. So, you know, if you've referenced Smith 2015, 6-legged robots, Journal of Robots, Volume 3, Number 6, 2012. If you've actually got that wrong, then by actually searching for that will tell you very quickly that actually you've got the citation wrong, and you can get it right before you put it into your document. Okay. Get familiar with whichever citation tools that you want to use, and therefore make it easy, make it a 0 barrier of entry for citing these documents for yourself for your final report. And what I would suggest, although I'm not going to check, so it is really up to you, I would, keep these notes on a paper by paper basis. I would suggest you write them as you read the report. It will be really useful information then when you construct your report, and these notes then should remain intact, but separate from your report. So it's a different document from the report that you will actually be handing in at the end. Keeping track of resources number 2 then. So as I said, it's important that you keep notes as you read these papers. And it may be necessary for you to return to the full text of a paper some weeks or months after you first read it. And that's why keeping the notes is important. You've read something, you've read some other things over the course of another month, and you think, oh, actually, yeah, that paper was really important. but I can't remember the details. I better go back and read it again. Okay, so keep, the best way I would suggest is you keep a record of those papers. Okay, and then that task becomes rather trivial. And there's lots of tools again that you can use for doing that. So we talked a lot about Google Scholar in the first lecture. So there's something within that called My Library, which allows you to keep a record of papers and even PDF versions. And there are these rather more formal things called citation managers, which you can get, which allow you to keep the database of your papers, but also keep PDF links. And one of these is something called Mendeley, which I'll show you an example of that in a few moments. Or you may just simply keep a folder of all the PDF files. And again, that's fine. That's fine. If that's what you want to do, then that's fine. What I would suggest is when you store the PDF, you rename it, and you name it in the format that you might reference it in your paper. So as an example, and I quite like this way of doing it, so that this is a paper that was published in 2011, and the first author was called Jenkins. Okay, so Jenkins 2011 is a nice, precise and easy format for that. And then if that's how you're going to reference it in your text, then in your citation manager or in your document that you're storing these in, you call it Jenkins 2011.pdf. And that's easy for you to find it. If a person actually writes more than one paper in a year, then you can cope with that as well by, here we go, Bodmin 2009A, Bodmin 2009B. So again, it is easy for you to do that. Okay, let me just give you an example now of one of these citation managers. And the one I want to show you is Mendeley. As I said, there are lots of others. There are really lots of others. So let me stop sharing this document. And let me share this. So this is happens to be my Mendeley document, but as I said, so this is what we call a citation manager. So what you'll see here is lots of papers, and you've got authors, titles, year, published in, when it was added, etc., etc. So I just pick on one here, which I've picked on this one here by an author called Hadow. So this gives the full details that you might want, that you might need in your thing. And over here on the right hand side, it gives you a lot more detail. So it gives you the full title, it gives you the authors, it tells you where it was published, so which journal, when, volume, issue, and the page. It gives you, you can add, sorry, it doesn't give you, you need to add this, but you can add the abstract. So this gives you the full abstract of the paper. It gives you keywords. It gives you, so there's the tag, so Hadow 2011. So that's how it will be referenced in the article that you write. It gives you the URL and the DOI if you need to do that. And even if you click here, it even gives you the paper. So you can actually get back to the paper again. Okay, so it's a really nice example. I can go down and look at another one down here. Here we go. So again, this is the paper. These are the authors. If you wanted to, you can look at the paper. And you've got lots of other information on there. Okay, so I'm going to stop sharing that one now. And go back. Go back to our presentation. So Mendeley is one, as I said, there are lots of others. Keynote, I think, is another one for Word documents. But the other thing with these is that if you use something like LaTeX, then you can automatically link in your publications from something like Mendeley into your report. So it's a really nice way. It keeps everything nice and ordered. It makes it easy for you to search. In 2 or 3 months after you've read a paper, it makes it easy for you to come back to it. So I really would strongly recommend that you do a little bit of investigation about citation managers and just get used to using one. It will be really useful for you both now and in the future, I would suggest. Okay, do I need to tell you this? Well, I'm going to anyway. Keep backups of your work. please, please, please back up your work on a regular basis. You know, I think many of us know people whose hard drives have failed, who've got all their data on a USB stick, and they fail. USB sticks actually fail quite often, in my experience. So you should aim to never lose more than, at maximum, a day's work, and I would suggest half a day's work. And there are lots of resources these days which allow you to be able to back your work up very easily, very quickly. So lots of cloud resources, Google Drive, Dropbox. There are university facilities to allow you to back up onto there. So save your work regularly. I would suggest twice a day. You know, you could do it at lunchtime and at tea time or something like that. So then if the worst case happens and your hard drive fails, you've only ever lost half a day's work in that thing. But so never more than that, certainly at least once a day, I would suggest you should be backing up your work. So please do that. I won't say any more about that. Let's move on to critical thinking. So this is something that may be quite different for many of you. Some of you may have actually done some of this before, but I suspect for most of you, it will be kind of a new topic, really, a new idea for yourselves. So up to now in your academic lives as students, most of you as students, you've mainly been exposed to a particular type of question. And that question, usually, it only contains assertions that are true, that you believe that are true. It often has a unique and correct answer. It's tractable with the resources that you have. So what I mean by that is that you've had your lecture notes, maybe you've got extra reading that the lecturer has given you, and actually based on all of that, all those resources that you have, you can answer that question, which is unique and has a correct answer. And as we saw in the first lecture, when we start doing searches on documents, things like Google, then actually it's not so tractable. The amount of resources you've got becomes very, very large. And then usually with the questions that you've been faced so far, all the information required in order to answer that question correctly has been made available to you and is true and accurate, or at least as far as you're concerned, is true and accurate. So now that world is changing. When you enter the world of research, it's important to realize that these types of questions, the questions which are bounded by these true assertions, the limited tractable resources, it's not actually so common. So we have to start thinking a little differently to what we've been used to. So here's an example, nothing to do with robotics. So in a paper by some random anonymous person called Clark, okay, Clark concludes that all biscuits are made of chocolate. And there's the reference to his paper or her paper. So it concludes that all biscuits are made of chocolate. Do we actually believe that? Do we think that's really true? Okay, let's delve a bit deeper. Why did they make that conclusion? So they made that conclusion because in their experiments, all of 100 samples showed a caraco, so the thing that we can count as chocolate, showing a caraco level of 21%. Were obtained from a single biscuit. So reading this, okay, so they've made some measurements, which is good in their experiments. They've done 100 samples, so that's good in that it's not just one. They've not just done one, but all of those samples were obtained from a single biscuit. From a single biscuit. So the fact that only one biscuit was sampled undermines the generality of the conclusions that all biscuits are made of chocolate. Okay, so it's a simple example, but when you think about it slightly more critically, that's the kind of conclusions that you might come from that. And therefore, we believe the conclusion that at least some biscuits are made of chocolate is supported by Clark's study, but not all. So this here that all biscuits are made of chocolate is not supported by the way that they did the experiments. But at least some biscuits are made of chocolate is clear, because of 100 samples of a single biscuit, it showed that there were caraco levels high enough to suggest that there was chocolate in there. So that's a really simple and I would suggest relatively straightforward way of identifying about whether the conclusions were correct, and somewhat how the conclusions were drawn, how they came to those conclusions. Okay, so this is actually taken from this reference down here. Okay, but it's quite a nice. It's a nice thing to get us going. So regardless of how many objective, technical, or scientific the subject matter, the authors will have made decisions during their research and writing process, and each of those decisions is a potential topic for examination and debate rather than blind acceptance for us when we read those papers. Okay, so the decisions that might have been made was, in that case, in the previous case we saw, was how many biscuits they were going to use to actually do the research. You need to be prepared to step into this academic debate and to make your own evaluation of how much you are willing to accept what you've read. So again, going back to our example, you know, we could quite critically go into that debate and say, yeah, but actually we think the general conclusions you've drawn are too general, that you've actually not done the experiments properly to make such a general conclusion to your work. A practical starting point, therefore, is to consider anything you read not as a fact, which I suspect you have done in the past when you've been an undergraduate, for example, so not as a fact, but as an argument of the writer. So the writer is suggesting this is true and opening up that as a debate, opening that to you as a series of questions. So you take this as a starting point, you'll be ready to engage in this critical reading and critical thinking. So I think that's a really nice way of putting it. If you think about it that way, that anything you read, it's the author is saying, well, this is what I'm suggesting, but I'm now opening this up for criticism. I'm opening this up to you to consider whether what I've said is true or not, or valid. Okay, so some practical methods to help to get you going when you start reading a particular paper. So when you're doing that, have the authors established an aim? Is it fairly clear in the text what the aim of the text is going to be? So you might expect that in the abstract or early on in the introduction. And we'll come and look in more detail about the structure of what these, of typically what papers and reports look at fairly soon. But so has there been a proper aim established? What assertions does the author make? Okay, so what are they proposing? What are they saying is true? How many biscuits have got chocolate in them? Okay, examining not just what the author's argument is, but how they got to it, how they constructed that argument. And sometimes what you'll find when you read papers is that construction part in a paper is rather vague. So they don't give you so many details. And the problem, if they don't give you the details, it's much more difficult for you to decide whether the author's conclusions that they've established are valid, whether the arguments that they produced end up making those conclusions obvious. So look at the arguments, the methods, and the data used to decide whether the conclusions are justified or not. Okay. And then look at the conclusions and decide, okay, have they been quite conservative? So they've not made outrageous claims based on a sample of one biscuit. Is the conclusion highly speculative? So I could suggest that the previous example that we looked at is quite speculative when it talks about all biscuits having chocolate in. Does the author give clear conclusions based on data and present some additional conjectures based on intuition? So sometimes what you'll find is that you'll read a paper and actually the first set of conclusions you're kind of happy with. You think that the data backs up and the experiments that have been done back up those conclusions. But then people start to go further and they say, okay, because of this, we can say this, without necessarily actually having done the results, having collected the results through experiments to make those conclusions. So think about that carefully when you're reading papers. Does the data justify the conclusions? What type of hypothesis and method is the author using? Okay, so is it a proof of concept? So we did this, so therefore it can be done. Is it a rather more sweeping statement of a belief? So swarm robotics is naturally robust to faults. So that's quite a large sweeping statement about all swarm robotic systems naturally being robust to all faults. Maybe that's what that's suggesting. Okay, I can tell you that's not true. Actually, as a fact, you know, all swarm robotics are not naturally robust to all faults. But I suspect if you look reasonably deeply, you will find some papers that say that. So is there a formal hypothesis that's being tested? And as a null hypothesis being rejected? I'll talk about what hypotheses and null hypothesis is in a minute. But first of all, actually, has that been specified and tested properly? Or is there a formal theorem? So there might be a mathematical proof, which I guess we might all think makes it more valid. How rigorous does the test, how does the method test the hypothesis? So this could be the number of experiments, the type of experiments, etc., and what results come up to with testing that hypothesis. Did the author construct their argument properly? So think about that. What are the steps that the author's gone through to did that? And you know, a really important point to really ask yourselves when you're reading papers and articles is did the experimental design have the potential to reject the hypothesis? So sometimes it's quite easy for people, because they know what answer they want, they produce a set of experiments which gives you that answer. So actually, was there a potential for it to reject the hypothesis? So let me stop sharing this screen. And let's go to talk about hypothesis just for a short time, just as an aside, just in case you've not come across this idea of a hypothesis before, and more specifically a null hypothesis. So here's some examples from this thought company as a link to the web page at the bottom. So a null hypothesis assumes there is no relationship between two variables, and that controlling one variable has no effect on the other. So that's a null hypothesis. So here's 3 cartoons, which gives null hypothesis. So cats show no preference to food based on shape. Plants growth is not affected by light color, and age has no effect on the musical ability. So these are null hypotheses. So 2 variables, one doesn't control the other. And what you would do in an experiment is to try and see whether that null hypothesis was true or not. And this is often used in experiments in science. So here's some text as well from this page. Let me make this bigger. So here's the reference to the text up here. So let's just talk a little bit about this, just so you've got this a bit clearer in your head. So a null hypothesis, which assumes that there is no meaningful relationship between 2 variables, may be the most valuable hypothesis for scientific methods based, because it is easiest to test using statistical analysis. This means you can support your hypothesis with a high level of confidence. Okay, so statistical analysis usually means that you've done lots of experiments as well to make sure that the results you get are statistically true. So if you were tossing a coin, you might toss a coin only twice, you get heads both times, and therefore you say your results could be, okay, that when you toss a coin, it always comes down as heads. Well, we all know that's not true. We all know it's a 50-50 chance. And that just simply means you haven't done enough experiments to actually come up with that statistical conclusion. Testing the null hypothesis can tell you whether your result is due to, effectively to manipulation of the dependent variable or just due to chance or is random. Okay, so what is a null hypothesis? The null hypothesis states there is no relationship between the measured phenomenon, the dependent variable, and the independent variable. You do not need to believe the null hypothesis is true to test it. On the contrary, you will likely suspect that there is a relationship between the two sets of variables. One way to prove that this is the case is to reject the null hypothesis. Rejecting the null hypothesis does not mean the experiment is bad, or in some respect you failed. That's actually what you want it to do. Okay, so let me just move to the bottom here. This PDF is on the wiki, so you can look at it in more detail. So here's a way of converting questions into a more scientific null hypothesis. So the question you've got, are teens better at maths than adults? So the null hypothesis, so turning this around, this question around, is age has no effect on mathematical ability. So you could then test that by giving various age groups maths problems to see whether that's true. Does taking aspirin every day reduce the chance of having a heart attack? So that's the question you're interested in answering. So the null hypothesis would be taking aspirin daily does not affect heart attack risk. Do teens use cell phones, mobile phones, to access the internet more than adults? So age has no effect on how cell phones are used for internet access. Do cats care about the color of their food? Cats express no preference to color. And does chewing willow bark relieve pain? There is no difference in pain relief after chewing willow bark versus taking a placebo. So you'll see, you should hopefully be able to see that you might have a question and you can turn that into a null hypothesis, and the null hypothesis is the thing you test. So this is the thing that you set up experiments for, to get data back for, to decide whether the null hypothesis is true or false. And you'll see that in a lot of papers. Stop sharing that page now. Let's go back. To our PowerPoint. Okay, so that's talked a bit more about our hypothesis and how we construct that. Okay, so let's think then finally at the end of an article, at the end of a paper, it's got some conclusions. So what extra data might they have gathered, might the authors have gathered, or have they got enough there? So one of the big problems, one of the things you'll find quite often when you read papers is that actually people haven't done enough experiments, which means that there's a point here, which means that are the statistical methods appropriate? And going back to the tossing a coin example, doing a couple tosses of the coin probably isn't enough to allow you to make any solid statistical conclusions about that particular experiment. So you need to think about that carefully. Do the experiments present an appropriate number of trials? Would the same experiment work on a different platform? So this is the generality question. So, if you were doing an experiment and you might say all robots are effective at moving upstairs, but actually the experiment was only done with legged robots, then that probably isn't a very good conclusion to make. Are there other equally valid conclusions to be made based on the experiments that have been done? So for us, because with the field that we're in science and in robotics in particular, almost all of the conclusions will be made after having undertaken some experiments. So that's kind of the crucial part of all is, are the experiments being constructed properly? Have enough experiments been done? Is the right data being collected for the conclusions that have done there? Okay, so what other hypotheses can be supported or rejected by the data? So the authors may have focused on one particular one, but reading the paper, you may have actually come up with other hypotheses that the data might have supported or rejected. And could there be additional control experiments being made to help reject these extra hypotheses? So this is the end of part 1 of lecture 2. And so here's the first task for our next workshop. Pick 1 or 2 papers in an area of robotics that you're interested in, and that include experiments. So it's important that it's a paper that it includes some experiments. Read these, and then with your new critical eye, so with the new things that we've been talking about in this lecture, what are your conclusions of the conclusions drawn by the authors in that paper? And then what I'd like to do in the workshop is we can have a bit of a discussion. We can share around some of the conclusions of these papers and have a bit of a discussion of your thinking of whether their conclusions are valid or not. Thank you very much, and there'll be part 2 coming up soon.